we have to prove that the sensitivity of Wheatstone Bridge will be maximum if all the four resistances of Wheatstone Bridge are equal. All the four resistances of a Wheatstone Bridge are equal. So in the diagram, four resistances PQ are X along with a battery form a Wheatstone Bridge, and four resistances PQRS form a quadrilateral ABCD. A constant current I is generated from the battery of EMF, and the current flows into the quadrilateral. I1 is the current which is flowing through the resistance P, and I2 is the current which is flowing through the adjustable resistance R. Ig is the current that is flowing through the galvanometer G, and through the resistance Q, I1 minus Ig current will be flowing, and through the resistance X, I2 plus Ig amount of current will be flowing, and we get total current I at the point C. And this is a Wheatstone Bridge. Four resistances PQ are X with a galvanometer G form ABCD quadrilateral, and that quadrilateral along with battery is called Wheatstone Bridge. In this case, R is the adjustable resistance. Values of that resistance can be changed to obtain the balanced condition of the bridge. R is the adjustable resistance of the circuit. The sensitivity of the Wheatstone Bridge is given by the quantity S, capital S, equal theta divided by dr by r. That is the expression of sensitivity of Wheatstone Bridge. S equal theta divided by dr by r. Hence, it is the deflection per unit fraction change of resistance R, where theta is the angle of deflection produced in the galvanometer G connected between the 2 points B and D. That is theta is the angle of deflection of the galvanometer G. Here G is the galvanometer connected between B and D, and theta is the angle of deflection produced in the galvanometer G due to flow of current. If greater amount of angle of deflection is produced due to small change in resistance, in that case sensitivity of the Wheatstone Bridge will be maximum. Also dr by r is dr by r is the fractional change in resistance of Wheatstone Bridge. Fractional change in resistance R connected between the 2 points A and B in the Wheatstone Bridge. If greater angle of deflection is observed due to small change in resistance in the Wheatstone Bridge, then the bridge will be very sensitive. The resistance R is connected between A and D. That's why S is equal to theta divided by TR by R. That is the sensitivity of the Wheatstone bridge. Now, angle of deflection produced in the galvanometer is directly proportional to change in difference in voltage between the 2 points B and D. So dV equal to VB minus VD, which is the potential difference between the 2 points B and D. That means the potential difference between the two ends of the galvanometer. Greater the potential drop or potential difference between the two ends of galvanometer, greater will be the deflection PD between the 2 points B and D. G is a galvanometer, and here VB is the potential at the point B, and VD is the potential at the point D. And del V is the potential difference between the two terminals of the galvanometer G. That means between the 2 points B and D. If uh, and in this case, if this potential difference is very large, angle of deflection will be very large, and sensitivity will be very high, and therefore theta equal to kdv, where k is constant of proportionality, and finally we get the expression of sensitivity, which is kr dv by dr. R is the resistance of the adjustable resistor connected between A and D. dv is the difference in voltage between the two terminals of the battery, and dr is the change in resistance of that adjustable resistor. Now, the potential difference between the 2 points B and C, that means the potential difference across the resistance Q. Now you have to find the expression of dV, that is VB minus VD. For that, first we shall find the potential difference between the resistance Q, potential difference between the 2 points B and C. So we have to remove this portion because it is incorrect. We have to find the potential difference between the 2 points B and C, not B and D. Erasing this part, this portion, and we have to write again. Potential difference between the two ends of the resistance Q, that is the between the 2 points B and C, is given by VB minus VC equal I1 minus IG into Q. I1 minus IG into Q. So if we draw the diagram again, the quadrilateral ABCD, four resistances are connected to form ABCD quadrilateral. Resistance P, Q, R, and X, not S, it should be X. In this case, sensitivity is denoted by S, and here the resistance is not S, it should be X, and a galvanometer of resistance G is connected between B and D. This current is I1 minus IG, and current flowing through the galvanometer G is IG. And at valence condition, Ig equal to 0, galvanometer shows no deflection, that's why Ig equal to 0, and current flowing through the resistance X, fourth resistance X, is I1 plus Ig, or comma Vb minus Vc equal I1 dot Q, where Ig equals 0 at balanced condition. We have to find the maximum sensitivity of Wheatstone bridge at balance condition. The bridge should be balanced. That means P by Q will be equal to R by S. Then we have to find the condition at which the sensitivity of the bridge becomes maximum. Ig equals 0 at the balance condition of the bridge. Now, what is the expression of current I1? Current I1 equal to EMF divided by total resistance of the branch containing P and Q. VB minus VC equal, in place of I1, we can write E divided by P plus Q. E divided by P plus Q, bracket close, into Q. So this is the potential difference between the two ends of the resistance, between the two ends of the resistance Q. So if we draw the diagram again, as Ig is 0, galvanometer has no function, galvanometer can be removed, and a battery of EMF E is connected to the quadrilateral. E is the EMF and I is the total current again, I, and potential difference between the two ends of the quadrilateral is again E. These are the four resistances P, Q, R, S. Current flowing through the branch containing P and Q is I1, and current flowing through the branch containing R and X is I2. It should be X, not S. Hence, I1 equal E divided by P plus Q, means voltage divided by resistance, and I2 equal E divided by R plus X. R plus X, not S. It should be X. We can erase that resistance. It should be X in the diagram. R plus X, and in the diagram again we have to erase the resistances. It should be X, not S. It is X. Correction is made. Is done. So I2 equal to E divided by R plus X. Current equal voltage divided by total resistance. So we get VB minus VC as, so to find the current I1, it should be E divided by P plus Q, and to find I2, I2 equal to E divided by R plus X. We get the expression of VB and VB minus VC, which is E divided by P plus Q into Q. Similarly, we can find the potential difference between the two ends of the unknown resistance X, that is VD minus VC, equal, this point is B, this point is D, and that point is C. So potential difference between the 2 points D and C equal I2 dot X. Therefore, VD minus VC equal E divided by R plus X into X. E divided by R plus X into X. Therefore, Vd minus Vc is equal to E divided by R plus X into X. That is the potential difference between the two terminals of the resistance X. That is the PD between the 2 points D and C is Vd minus Vc. Now, Vb minus Vc minus Vd minus Vc equal, E is taken common, under bracket Q divided by P plus Q. Q divided by P plus Q minus X divided by R plus X. Therefore, Vb minus Vd equal E Q divided by P plus Q minus X divided by R plus X. Bracket closed. So this is the potential difference between the two terminals of the galvanometer G. That is the potential difference between the 2 points B and D of the Wheatstone Bridge. Now the sensitivity is K R dV by dr, and here dV is what? Vb minus Vd. K R Vb minus Vd, it is incorrect. So here we have to do Kr. DDR of V, we have to remove this or erase this part. KR DDR of V, d by dr of V. Here V is what? VV minus VD, potential difference between the 2 points B and D. KR d by dr VV minus VD, bracket closed, equal KR. Now we can put the expression of VV and VD. E is taken common outside DDR. Uh, DDR of Q divided by P plus Q minus X divided by R plus X. R plus X, not S, it should be R plus X. KRE DDR of Q divided by P plus Q, bracket closed, and DDR of X divided by, it should be X, not S, X. DDR of R plus X whole to the power minus 1. This is the expression of, now we can differentiate KRE. This term will be 0. DDR of Q divided by P plus Q is 0, because Q divided by P plus Q is 0 is constant. That's why DDR of Q divided by P plus Q equal to 0. Minus X into minus 1, R plus X to the power minus 2, and DDR of R plus X, bracket closed, equal KRE X divided by R plus X, X into R plus X whole to the power minus 2, and into 1, because DDR of R plus X is 1. Hence we get the another expression of sensitivity, which is KREX divided by R plus X whole square. So S equal KREX divided by R plus X whole square. S equal KREX divided by R plus X whole square. This is the sensitivity of the Wheatstone Bridge. If the Wheatstone Bridge is most sensitive, if the Wheatstone Bridge becomes most sensitive, becomes most sensitive, comma, S will be, sensitivity will be maximum with respect to the resistance R. Therefore, DDR of S equal 0, because if S is maximum, S is constant. That's why differentiation of S with respect to the resistance R. That means DDR of S will be 0. So now DDR, putting the expression of sensitivity S, KEX R divided by R plus X whole square, bracket closed, equal 0, or comma, KEX R constant we can bring outside DDR. KEX DDR R dot R plus X, R dot R plus X whole to the power minus 2, bracket closed, equal 0. R is brought outside DDR. DDR of R plus X whole to the power minus 2 plus R plus X whole to the power minus 2. It should be plus R plus X whole to the power minus 2 DDR of R equals 0. It should be plus. Or comma R under bracket minus 2 R plus X whole to the power minus 3 DDR of R plus X plus R plus X whole to the power minus 2, and DDR of R is 1 into 1 equal 0. Or comma minus 2R divided by R plus X whole cube. DDR of R plus X is only 1 plus 1 divided by R plus X whole square. R plus X whole square equals 0. Now R plus X whole square is taken common. 1 by R plus X whole square is taken common. 1 by R plus X whole square. Under bracket minus 2R divided by R plus X plus 1 bracket closed equals 0. Therefore, minus 2R divided by R plus X plus 1 equals 0. Or comma 2R divided by R plus X equal 1. Or comma 2R equal R plus X. R plus X equal to R. Therefore, R equal to X means the value of the resistance of adjustable resistor will be equal to the other resistor connected between D and C, that is X. R equal to X. Again, at the balance condition of the Wheatstone Bridge, at the balance condition of the Wheatstone Bridge, P by Q equal R by S. Ratio of resistances above the galvanometer, that is P by Q, will be equal to the ratio of resistances below the galvanometer, that is equal to R by S. Or comma P by Q equal to 1, since R equal S, R equal X. In the expression P by Q, it should be R by X, not S, because S is the sensitivity in this case, since R equal to X. Therefore, P equal to Q. Hence, it can be written as, that is P equal to Q equal to R equal to X. It can be written P equal to Q equal to R equal to X, because R equal to X and P equal to Q and P by Q equal to R by X. That's why we can write P equal to Q equal to R equal to X. That means all the four resistances will be equal if the bridge is most sensitive. The sensitivity of the bridge will be maximum. Therefore, the Wheatstone Bridge becomes most sensitive, will become most sensitive, will be most sensitive if the four resistances in the quadrilateral of the bridge are equal. Four resistances of the bridge are equal. That is the condition at which Wheatstone Bridge becomes most sensitive, or sensitivity S becomes maximum. So additional information: if P equal R equal X, not S, it should be X. P equal Q equal R equal X, not S, comma, the sensitivity S tends to S max, means sensitivity will be maximum. and the expression of S is theta divided by dr by r, that is uh, deflection per unit fractional change in resistance dr by r, not dr by dr. Number two formula is theta equal to k dv, where dv is the potential difference between the two ends of the galvanometer, which is Vb minus Vd. Number three, S equal Kr K dot R dV by dr. dV by dr is rate of change of voltage with respect to change in resistance. And S has the final expression, that is Kex R divided by R plus X whole square. So this is the